Hello and welcome to day 6 of our SAT master classes. Today we're on day 6 of our maths. Last time we were talking about ratio, rates and proportion, unit conversions and percentage. As I say, we're going to move towards the graphical section of our SAT. So the question that we're dealing over here involves graphs, scatter plots and points, and we have to know the different pattern in the points itself to find out the answers. So our topic today are center spread and shape of distribution, scatter plots, and linear and exponential growth. The first topic of the day is center spread and shape of distribution. Our Ismasi will be talking about five things, five topics that we have studied for I guess 3-4 years already. So it involves mean, median, mode, range, and standard deviation. Over here, sometimes calculation related to mean, median, or mode से गर्नुपर्ने हुन्छ. तर most questions related to range and standard deviation say are going to be graphical. भनेपछि we won't have to remember the long formula and our standard deviations, or we do not need to do particularly any calculation. गर्नु परे पनि एकदमै सिम्पल क्याल्कुलेसन गर्नुपर्ने हुन्छ अनि जति पनि डेटा पोइन्ट्सहरू दिएको छ हाम्रो ग्राफमा त्यही युज गरेर चाहिँ we just have to find the answer. So I guess it does make it a bit easier for the students who find it hard to remember formulas. So, introduction. We first need to know what center and what spread basically means. So, center basically is a typical data or just one data. So, I'm like 10, 15, 20 or data points they go like 11, 12, 13. यसरी दिएको छ भने यसबाट if the answer that we are finding involves of only one certain data, for example, maybe the answer is 20 or maybe the answer is 11, then that is basically center. And to find गर्ने any of such topic falls under center. Therefore, SAT मा चाहिँ we cover three measures of center, which is mean, median, and mode. एकछिन सोच्नुभयो भने you realize that your तीनटैको आन्सर गर्दाखेरि you'll only find out one certain data point of view. We're not trying to find out a bunch of set of data or a range of data. Mean भन्ने बित्तिकै we already know mean is the average of a certain data. Median भनेको is going to be the middle term or the middle number in a certain data only when it is arranged in an ascending order, right? And mode भनेको चाहिँ the number that is most frequently shown in a certain data. So जुन number चाहिँ सबैभन्दा धेरै एउटा data set मा आइरहेको छ त्यो number चाहिँ is our mode. We'll be talking more about this in depth पछि, and let's move on to what is spread. So spread ले चाहिँ हाम्रो variation show गर्छ in a certain data. And you'll see we're going to calculate using range and standard deviation. यसमा चाहिँ we're basically finding out how many data points are between a certain minimum or a maximum, or we're trying to find out कतिको spread छ or कति चाहिँ data मा चाहिँ variation छ भनेर. Now, like mentioned over here, mean basically means the sum of the values divided by number of values, which just means the average of any certain data point. Moving on, what is median? Median is the middle value when the data are ordered from the least to the greatest. This is one thing that we have to remember, and it's something that we end up forgetting. Carelessness nahi hona shayad exam ma. But we don't try to arrange the data in ascending order. त्यो गर्ने बित्तिकै the answer that we try to find out will most likely not be correct. Another thing that we have to remember is that median is the middle value. When we are given odd number of data, for example, we are given 7 data sets, 1, 2, 3, 4, 5, 6, 7. Then the median is definitely going to be the fourth data set or the fourth term over here. However, when we are given even number of data, for example, third fourth is definitely not going to be the middle term. The middle term is going to be between these two. So in this case, we have to use the two middle data, which is going to be the third term and the fourth term. We have to find the average of those terms and we have to divide it by 2. That is going to give us our median. And now moving on to mode, like mentioned, so the data appear when the number is in our data set is going to be mode. A data set can have no mode bunny if no value appears more than any other, or a data set can also have more than one mode. For example, if this data set was given, a number hasn't been repeated even twice, so there is no mode. But for example, In this case, the number 9, number 6, and the number 8 has been repeated twice. So all of these number 9, 6, 8 are basically modes. Above, we have to understand the spread side, which is the range and the standard deviation. Range money with the K, it is the total spread of the data. Total spread basically means हाम्रो minimum value र maximum value भित्र जति पनि data point पर्छ. Of course, the minimum and the maximum value are also going to be involved. So all the data sets मा चाहिँ कतिको difference is our range. Hence, the formula of range is maximum value minus minimum value. And also range is directly proportional to the spread of the data. Here we are given two different data sets, 1 and 2. Let's take an example over here. So the minimum value in the first data set is 5, whereas the maximum value is 15. In our data set 2, however, the minimum value is 0 and the maximum value is 20. Our range निकाल्ने बेला, the range of this comes out to be range 1 becomes 10, range 2 becomes 20. So, what do we know from this data? That the range of the second set of data that we're given is greater than that compared to the first set. Vanibitike, the spread of the data in the second data set is राम्रो or is better or bigger than compared to the first spread of the data. Similarly, standard deviation is the measure basically measures the typical spread from the mean. So at a certain value को चाहिँ meanबाट कति distance छ or कति difference छ त्यो measure गर्ने काम चाहिँ standard deviation को हो. It is the average distance between the mean and the value in the data set. Now over here it's important to know what the mean is. For both the data set actually the mean ends up being 10. As we already did it from range, we know that dataset 2 co range spread is greater than that of 1 co. But we can find out the same thing by using standard deviation as well. In our first dataset, the mean is 10 and so the Tara co value from 10 is 15 and 5, which are placed in the same level of distance. So it's equidistant. In the same way, second graph upon the mean the 10 neo, but the maximum value or the farthest value is 20 and the farthest value in the other side is also 0. We can see that the distance from 0 to 10 or 10 to 20 is greater compared to 5 to 10 or 15 to 10. Hence, we know that the spread of the second data is greater than that of the first data, into this distance itself is larger. And that is how we normally use standard deviation or how we solve any question related to standard deviation. Now we need to also understand what outliers are. It's a new topic or a new word for pretty much all of us. An outlier is a value in a data set that significantly differs from other values. Basically, certain times when we're solving any kind of graph, if data are in this order, which is going in a straight line, one point can be given such that it's over here or it's over here. While this line follows a general trend, these points which are completely outside the general trend can be known as the outliers. Now, how do the outliers even affect the spread or the center of the data of our points that we're trying to find out? So, an effect of outlier on spread. When an outlier is included in the data, then the spread increases and vice versa. Outliers are numbers that differ largely from our normal data. भनेपछि like mentioned अघि पनि एउटा certain row मा गइरहेको छ भने यसले र यसले त हाम्रो trendलाई break गर्यो, but it also increased the variation itself. Instead of the data being composed only यो line भित्र, उ त अब यो line मा पनि छ, यो line मा पनि छ. So our data is from here to here, basically increasing the spread in general. Hence, outliers हुने बित्तिकै हाम्रो data को spread चाहिँ बढ्छ. How it affects our center? First mean and second median. Mean मा चाहिँ if a large outlier is removed, the mean of the remaining value will decrease. For example, in a list of numbers 9, 10, 18, 17, 16, 30, and suppose 101. In this case, 81, sorry, 101 is completely out of the normal trend. But if this number is removed, then since the highest number is removed, the vanity हाम्रो mean is going to be smaller. Similarly, when a small outlier is removed, for example, 9 is removed, which is the smallest number, to remove vanity or maybe we have an even smaller outlier. Suppose 1 छ भने 1 remove भने बित्तिकै हाम्रो mean को value चाहिँ significantly बढ्छ. Similarly, in median, if a large outlier is removed, the median of the remaining value will either decrease or remain the same. So, kind of similar to mean, large outlier निकाल्ने बित्तिकै value को चाहिँ दुईटा condition हुन्छ. Either it will decrease like in the mean or it will remain the same. And if a smaller outlier is removed, then the median of the remaining value will either increase or remain the same. Now let's work out a question over here. A graph gives the average temperature in degrees Fahrenheit for city A and city B over the same 7 days in March. Let MA and SA be the median and standard deviation of average temperatures for city A, and let MB and SB be the median and standard deviation of the average temperature in city B. Which of the following is true? And we're given 4 different points. Either median of A is going to be greater than median of B, or median of B is going to be greater than median of A. And either the standard deviation of A is going to be greater than B, or the standard deviation of B is going to be greater than A. So, first of all, let's look at the data that is given over here in this graph. Let's try to find out first the standard deviation. Now over here we can of course count or calculate the mean itself, or mean by distance itself निकाल्दा पनि हुन्छ. But let's try to use some common sense in this question. About 1 to 7 days calculate गरेको छ, so this distance and this distance is going to be the same. However, the distance over here, therefore the points plotted over here for city A is from almost 60 to almost 40. So the range over here itself is about 20. Or in general, the spread of this data is the mean could be anywhere over here, and the distance over here and over here seems to differ. Whereas in city B, the spread of the data is from 52, 53 to about 50. So comparing the variation in the data itself, इसको mean maybe 51 ounce होला, whereas इसको mean about 45 ounce होला for city A and for city B. If you're trying to find a very general or just somewhat answer, but the thing is, Bima, the variation is not that big enough. It's from like 52 to like 50. So of course the spread of this data is much less compared to city A. Therefore, we know that the standard deviation of city A is greater than the standard deviation of city B. Hence, our answers is either going to be this or this. These are not going to be our answers. Now we have to find out the median itself. If you try to calculate the median, we know that it's from ascending to descending. That we also know is the middle point Canada. Throughout the data for our city A, if we're trying to go in our ascending order, then we have to follow from day 7 to day 1. And in this case, since the data are pretty perfectly aligned, so it's going ascending order without any problem, the data is most likely going to be in our 4th day, which is over here. And ISCO data is 40, so MA is 40. Whereas if you're trying to go in the same way, because it's pretty ascending order way, the data of the city B is anywhere anyhow bigger than that compared to the median of data set A or city A को, किनकि इसको 40 छ, and any number of the data set B is already greater than that compared to 40 itself. So MB is greater than MA. Now we only have one answer which works with that, which is 3. So this ends up being our answer. So You can see that I barely did any calculation in this question, and that is the point. You're not supposed to do a lot of calculations. It's basically just based on how you understand median and spreads and centers itself, and trying to use whatever you've learned to try to find out an answer. Now, the second topic of the day is going to be scatterplots. Over here, we'll be talking about data representations, graph of linear and quadratic equations, and exponential graphs. So, we'll study different type of graphs कसरी बनाउँछ कस्तो हुन्छ त्यसलाई आइडेन्टिफाई कसरी गर्ने अनि त्यसबाट कुन कुन डेटा पोइन्ट्सहरूलाई चाहिँ लिने र कसरी लिने when we have to solve any question like that. So the first topic over here is going to be scatterplots math, the data representation itself. So here we need to know what line of best fit means. So a line of best fit describes the general trend based on all of the points given to us. As we can see in the graph shown over here, points of course are going to be so many over here and they're not going to perfectly align together because that's just not how it works. But we can try to find out a line which is the closest to all the points given. Like someone close their round person. And we can see that there's this point which, like we mentioned in our previous chapter, we can call it an outlier because it's completely outside of the trend of line or the line of best fit itself. But most of the other points, of course, do not align perfectly, that the distance is much lesser. So this itself is called line of best fit. Now, how to predict the best answer? Over here again, we're not going to do any calculation. We're trying to use our logical skills and whatever we've learned to find out how to get the correct answer. Now, always use the line of best fit instead of individual data points. The most important point, because कतिधेरै पोइन्टहरू just like your outlier एकदमै टाढा भएको हुन्छ then the line of best fit. त्यसले गर्दाखेरि चाहिँ we can get distracted from our original goal or from the right answer. That's why it's always important to only follow the line of best fit, and using the line of best fit we can even do smaller equations and find out equations to solve answers. If the prediction line is the prediction lies between the part of the plane shown, it must lie on the line of the best fit. So basically चाहिँ के भन्नु खोजेको भन्दाखेरि जुन पनि certain prediction चाहिँ हामीले बनाएको हुन्छ, whatever we're trying to find, it must always lie in the line of the best fit. Otherwise, it will not work out. Basically, kind of the same point as before. And if the prediction lies beyond the part of the plane shown, we can either extend the line of the best fit or use its equation to find the prediction. So हामीलाई अहिले चाहिँ we can only see y till 20 and x till 25. But the answer may be beyond these coordinates पनि. त्यस्तो केसमा चाहिँ we can always drag the line of the best fit, since we have an option to draw in our question in our SAT as well, and then we can use this line to basically predict a certain answer. So the best way to find out answer is to use the line of the best fit and to play along with it to find the correct answer. Inserting scatter plots in linear and quadratic equation. So the case one is going to be linear equation. जुन चाहिँ y is equals to mx plus c or fx is equals to mx plus c हो. Do know that at times instead of writing c, they also write mx plus b because the y-intercept is shown using b in a US education system. Here, pay attention to the sign in front of the slope and the y-intercept. So basically, हाम्रो slope भनेको m हो, तर slope if positive goes at a negative भयो भने instead of this direction is going to go like this. So we have to pay attention to that, and of course the y-intercept itself. Y-intercept भन्ने बित्तिकै y axis मा चाहिँ कुन certain coordinate मा चाहिँ छोएको छ. For example, if this is 0 and if this is 1, sorry, minus 1, then the y-intercept or c or even b of this certain line is going to be minus 1. So the equation itself is going to be something like mx minus 1. Now also make sure the slope of the graph matches the slope in the linear equation. So जुन दिएको एउटा slope छ त्यसको जुन graph छ त्यसको जुन slope निकाल्छ त्यो चाहिँ should match completely with the slope that we're using in the linear equation itself. And also we can always approximate the value of y-intercept, and in most SAT questions it's given pretty well नै they still say whole numbers may राखेको हुन्छ instead of fractions or any such numbers. Now case 2 say is going to be quadratic equations, and the equation over here is going to be like this. If the value of a is for first thing that we need to know is that quadratic equation to slopes, sorry, graphs are not going to be straight lines. It's going to be parabolas, either face like this or this or this. It depends. Now the variables that are given over here are a, b, and c, and they play pretty much important roles in finding out parabola कसरी shaped हुन्छ र कसरी बनेको हुन्छ. If the value of a is positive, then the parabola opens upwards like this, sorry, like this given graph. But if the value of a is negative, then the parabola opens downwards. So तलपट्टि फर्केको हुन्छ like over here. And make sure that the y-intercept matches. Y-intercept, or in this case again c, for example if this is 2, then it has to match completely over here, and instead of c यहाँ 2 लेखेको हुनुपर्छ. So a र c को भ्यालुलाई चाहिँ इम्पोर्टेन्ट नै राख्नुपर्छ, अनि त्यसको बेसिसमा नै we are going to find out most answers in हाम्रो scatterplots related questions. Now the first question given, the scatterplot above shows y, the number of employees remaining in an office building, x hours after the building's air conditioning stopped working. Of the following equation, which best models the data are in the scatterplot itself? Now over here, we can always try to draw in a line of best fit ourselves and try to use the first and the last points that is given. And mostly हाम्रो scatterplot यस्तै हुन्छ, sorry, line of best fit यस्तै हुन्छ. अब यसबाट one thing clear भइसक्यो, the line is going downwards, which means that the slope is going to be negative. So you already know C or D is not going to be our right answer at all. Now another thing that we need to know is that this is supposed to be a parabola cone, right? So basically when we see this, we see that, I mean, we can use the same logic that I used to try to find the slope like this. Tara, because this is a parabola, यस्तो curve बनाउन मिल्यो. And similarly, this half of the end would be like this, which shows that the parabola is going downwards. Hence, A is negative number. So either A or B is going to be our answer. Now we have to move, since you already know that it's either A or B, we can use the y-intercept, the C part, to find out the correct answer. In this case, C is almost 300. So which is positive 300. Above 0. So B is going to be our right answer. It's positive 300. Like again over here, I'm not using any calculation. But I'm doing it just based on the value of one slope, or it depends. If you're trying to do linear, then the slope and the y-intercept. If we're trying to do it in a parabola, then A ko value is positive ki negative and C ko value. This should be more than enough to help you out answer any type of questions related to this. Now, linear and exponential growth. Over here, we'll find out the relationship between linear and exponential growth and how it particularly works. I particularly found it a bit difficult at times, Kineki. You do have to use up quite a lot of time questions that does not involve graph. This match we have to find out if the equation is linear, if the relationship is linear or exponential, which means it's being multiplied by the same number or not. Introduction. An example for linear and exponential growth can be probably the best way of explaining how it works. Rita's number of followers increased by 10 each day, which means that if she had X number of followers on Sunday, she had X plus 10 on Monday, X plus 10 plus 10 on Tuesday, X plus 10 plus 10 plus 10 on Wednesday. This shows a linear relationship of the number of followers Rita has. Similarly, Aisha's number of followers increased by 10% each day, which means that the first day ma 90 sorry X थियो भने the next day 10% of X ले add भयो. त्यसपछि जति पनि यो number छ 10% of whatever this becomes, suppose this becomes y ले add भयो. So as you can see, this becomes really complicated if you're trying to put plus plus sign use गरेर. Hence, in this case, we have to use it in a better way and try to use exponential growth equation itself, which is y is equals to a b x, where it's being multiplied by the same value over and over again. Linear math, same value is being added over and over again. So I think a few phrases and knowing how it works, these phrases work, is going to help you know if the word problem given to us is linear or exponential भनेर. अब फर्स्टमा चाहिँ चेन्जेस भनेको छ अनि increases or decreases at a constant rate भन्ने word युज गरेको छ भने चाहिँ it's going to be linear किनकि it's increasing or decreasing at a constant rate. If we're trying to do exponential growth को formula use गरेर then every day certain percentage add भइरहेको छ नि त, so the next day मा चाहिँ we cannot use the original value. त्यही भएर चाहिँ लिनियरमा मात्र constant नम्बरले बढ्छ. Changes by c per unit of time. Again, changes by c, the number to c is not increasing particularly. For example, अर्को example मा भनौँ 10 plus 10 plus 10 ले एड भइरहेको थियो, whereas एक्सपोनेन्शियलमा चाहिँ 10% x plus 10% of x भन्यो भने 10% of x was for Monday, but for Tuesday it's going to be x plus 10% of x. So we're not going to add 10% of x again, we're going to add 10% of x plus 10% of x. So the number that we're adding has increased. The number that we're using is different each time. It's not constant, unlike in linear. This is the reason we can find out whether an equation is linear or if it's exponential. Now, changes by c%. Most of the time, percent sign हुने बित्तिकै it's going to be exponential. So keep that in mind. By c% per unit of time. Percent sign राख्ने बित्तिकै it means that every time that we're adding it, it's going to be a bigger or a smaller number. It's not going to be the same number every time. Changes by c% of the initial value per unit of time. Now, this is, I guess, what confuses me and a lot of students most of the time. Changes by c% per unit time. So by c% per unit time is the situation created. So different numbers are being added every day or every time, whatever we're given. Changes by c% of the initial value. भनेपछि यो केसमा चाहिँ if x मा 10% of x भएको छ भने अर्को दिन पनि 10% of the initial value which was x ले नै add भइरहेको छ 10% of x, and another day again 10% of x ले add भइरहेको छ. So the thing that is getting added up is not changing every day, it's the same. Hence this equation is going to be linear. So it's very important to put special care in the words that are being used. Changes by a factor of c. Factor भन्ने बित्तिकै it's a multiplying, you're using multiplication, hence it's going to be exponential. Example, halves or double, it's getting half, it's getting double, blah blah blah, so that can happen. Now here's a certain example given for us. An investment lost approximately 5% of balance each month for the past year. The amount of investment on January 1st of last year was $10,000. Which of the following function L models the number of amount of investment in thousands of dollars at the end of the month n, where 1 is less than is equals to n, which is less than equals to 12. Basically, in a year मा चाहिँ कति भइरहेको छ भनेर सोधेको छ. If you do not understand the question once, please go to the question again, just in case it confuses you. Now, it's what we need to find out first of all if the equation is exponential or linear. If it's linear, then the answer is either going to be B or D. But if it's exponential, the answer is either going to be A or C. Again, let's read the question. An investment lost approximately 5% of the balance each month. It's losing money, most likely it's going to be using either a negative sign or it's going to be multiplied by a smaller number. Right? So it's either going to be this, B, or it's going to be C. Which of the following function in the amount of investment on January 1st of last year was $10,000. Which of the following function I models the number of investment at the end of the month. So 5%, this line is basically going to give us the answer to this question. An investment loss when we know that it cannot be plus sign at all. It's not D, and it's a loss again. 1.05 for author is that 5% add udesa, but in this case it's being minus. So it's either going to be 0.95 sang multiply or it's supposed to be minus. So A can also not be our answer. So it's either B or C. Approximately 5% of the balance each month of the past year. 5% of the balance each month. So each month जति balance हुन्छ after 5% loss त्यसकेबाट चाहिँ अर्को 5% loss त्यसै अर्को वर्ष गर्छ. So if in the month of January $10,000 थियो and that is getting multiplied by 0.95 when a certain number बाँकी हुन्छ. अब त्यो number again is going to get multiplied by 0.95 and again. So in that way, we know that हरेक महिना चाहिँ it's getting deducted by a different number and not a same number. Hence, it's going to be the right answer for us is going to be C and not B. Why? It's not a linear equation, it's an exponential equation. An exponential equation are always kept in this certain equational format. Now moving on towards the third topic of the day, which is exponential graph. हामीले exponential equation त कस्तो हुन्छ पढि नै सक्यो, which is basically y is equals to a b x. So we have to use this equation and we have to just find out the answers in the graph following this equation. Now यसमा चाहिँ exponential graph functions को बारेमा पढ्नुपर्छ and also how to identify the features of exponential function. So that itself was the end of our Day-6, where we learned about exponential graphs, we learned about the center and spread of the data, we also learned about scatter plots and how to deal with them. In the coming day, we'll be learning more on different topics.